Hello, my name is Chris Ray from the University of North Carolina at Greensboro, and I will be presenting this collaborative project titled Neuromotor Changes After a Concussion Are Detected with a Custom Smartphone App. Concussions have been implicated as a major public health problem due to what we have learned in recent years about the acute and chronic effects of concussions on physical and mental health. Concussions have widely been studied in the sports space, with efforts such as the NCAA-DoD Grand Alliance Care Consortium enrolling thousands of collegiate student athletes. However, this issue persists in military settings as well, where head trauma can occur from blast injuries occurring from primary, secondary, and tertiary blast-induced trauma. Since a concussion affects the central nervous system, neuromotor control tests, and more specifically, balance tests, are commonly given to assess the person's current neurological status. While there is a long list of tests that have been developed and are commonly used in this space, two of the more commonly used ones are shown here. In the middle is the BEST test, where the person attempts to stand in single or tandem stance and as still as possible. This test is done on the ground and on foam for 20-second trials, and the test administrator counts the number of times the person moves from their starting position. On the right is the Neurocom SOT that uses a moving force plate and a visual surround to quantify sensory ratios during the static balance test. While the BEST and SOT have been valuable tests over the years, they are both static tests, and it is known that dynamic tests are more sensitive at picking up neuromotor changes after a concussion. Further, the BEST is a subjective test, which has led to questions about its reliability. And lastly, the SOT is relatively expensive, creating a barrier for widespread use. To address these challenges, our research team created a smartphone app that uses the sensors in the phone to monitor a person's dynamic balance control. The video shows the process of starting the app, inputting basic participant information, and placing it on the participant's thigh. They then step in place for 70 seconds while the phone measures spatial and temporal aspects of their balance control. This test is done with the eyes open, eyes closed, and while shaking the head from left to right, with the last two conditions probing sensory contributions to dynamic balance control. In our previous work, we compared our smartphone app to gold standard laboratory equipment and showed that it produced clinically acceptable validity and reliability. We have also published the clinical utility of a previous version of our app, showing that military personnel who received repeated subconcussive head trauma from blast exposure had neuromotor dysfunction for up to 3 days after their blast exposure. While our previous work focused on those who experienced subconcussive head trauma, this current study focused on those with a diagnosed concussion, with the purpose to examine the app's clinical utility in a large cohort of concussed and non-concussed individuals. It was hypothesized that concussed participants would exhibit greater variability in their dynamic balance control. This was accomplished by enrolling 205 participants, 61 of whom had a concussion. All participants completed our stepping in place protocol with a smartphone attached to their thigh. To address our hypothesis, we focused our analysis on the standard deviation of the maximum velocity of the thigh as an indicator of movement variability. The results showed effects at both the group and condition level, with the concussed participants exhibiting higher variability than the non-concussed participants in the eyes closed and head shake conditions. A recent meta-analysis showed that increased movement variability is commonly observed after a concussion, and our data support that observation. It is important to note that our app is only an observational tool, so a deeper dive into a person's symptomology and other neurological markers is necessary to make medical decisions. Nevertheless, our data show that our smartphone app is able to identify neuromotor dysfunction after a concussion, thus providing an objective, portable, and cost-effective tool to clinicians and researchers. A follow-up analysis on the sensitivity and specificity of our app will be presented at the upcoming Military Health System Research Symposium. Our funding information and my contact information is here, and thanks for attending our talk.